Hello, mathletes. We are going to talk about factoring trinomials where a is not equal to 1. So generally you're going to have numbers where a is greater than 1, but you could also conceivably have numbers where a is less than 1, like not necessarily a fraction or decimal, but something where you have a negative value for a. Now, you always want to factor out the negative. If the leading coefficient is negative, you always want to factor out a negative anyway. And so generally it'll turn out to where a is greater than 1. And so that'll generally be the case. So, sometimes these are called complex trinomials or complex quadratics, where when a is greater than 1. And then the ones we dealt with before, when a is equal to 1, those are called simple quadratics or simple trinomials. Okay. All right. So this one's one of the more challenging things that I think we'll do, at least in my experience. This is something that tends to be, something that we need a lot of practice on, and that, takes some time to get in. So really dig in on this lesson. Make sure you're taking really good notes. Make sure you're, paying attention, and make sure your focus is singularly on this task here. Okay. And to start out, this is maybe the key skill, I think, in this method that I'm going to show you. And there's a few different ways to factor out complex quadratics. And I'm going to show you one, but I'll try to give you some resources for some different methods. And I'm okay with you using any method. This is just the one that I've found to be the most systematic and the most consistent. Whereas some of the other methods, may be better in some cases. That sometimes they can take a lot longer in other cases. And so this one I think is very systematic. All right, now 3 out of the 4 methods that I know of need this technique here, where you make a list of factor pairs. Okay, and then there's one method that doesn't use that, and that's the trial and error method, which once again, it could be quick sometimes, but it also could take a long time if you don't have your if you don't get the right mix to begin with. All right, so anyway, so I'm going to make a list of factor pairs. So this is not a factor tree, right? I'm not breaking this down into prime numbers and going from there. What I'm doing is I'm making a list of pairs that I can multiply to get this number. Okay, so we'll start with 216, and I picked one that's intentionally long. Like, not all of them will be this long, but I just wanted to show you kind of the complete setup and the complete process. Okay, so 216. I'm going to start with 1. That's a good place to always start. 1 and 216. Those are numbers that I can multiply to get 216, right? 1 in itself. So that always works as a starting point. Then I would ask myself, does 2 go in? And whenever the number ends in an even number, 2 is going to go in, right? And so I just, on my calculator or in my head or, on paper, however you want to do it, you can divide 216 divided by 2, okay? And that will get you this other number here, which in this case is going to be 108, okay? And then I'm going to check, does 3 go in? 216 divided by 3 is 72, right? A trick with 3s is if you add up the digits of the number, if they add up to a multiple of 3, that means 3 goes in. So 2 plus 1 plus 6 is 9. Since 3 goes into 9, 3 will also go into 216. So that's a trick with 3s. I think we might have put that up on the board a while back, but yeah, if you have questions about that, I can show you a little more in a little more detail there. And another way to check is just divide, right? 216 divided by 3. If it didn't go in, then you would get a decimal, okay? If it wasn't a factor, I should say. All right, and then 4. 216 divided by 4, is that a decimal? No, 4 goes in 54 times, right? Okay. Now 5, does 5 go in? Well, we know the number has to end in a 5 or a 0 for 5 to go in. And so 216 divided by 5 would be a decimal, or we can just know it intuitively by knowing that it ends in a 6, not a 5 or a 0. And so 5 doesn't go in, okay? So I'm just going to put an X through the 5. Okay, does 6 go in? 216 divided by 6, yes it does. It goes in, let's see, 36 times. Okay, so then we check, does 7 go in? 216 divided by 7 is a decimal, so that doesn't go in. Okay, there's not a real great way to check for 7s that I know of, at least. Maybe you can find a cool way. Let us know. All right, 216 divided by 8 is 27. Okay, so 8 goes in. 216 divided by 9. Let's see, does 9 go in? And actually the trick with 3's works with 9 too. So if you add these up, they add up to 9. Since 9 goes into 9, that means 9 will go into 216, or 9 is a factor of 216. And it happens to go in, let's see, 24 times. So then 10, does 10 go in? Well, it doesn't end in a 0, so 10 won't go in. 11, 216 divided by 11, that doesn't work. 12 actually goes in 18 times. 216 divided by 12 is 18. Okay, so then you check 13. 13 doesn't go in. If you divide 216 by 13, that's a decimal. 14, same thing, you get a decimal. 15 gives you a decimal. 16 doesn't work. 17 doesn't work. So here's where you kind of start thinking about, okay, where is this going to end, right? And here's where it ends. When you get to 18, when you see a number that's already on the other side of your list, that means you're done, okay? And so so that means our list is done, and these are our values, is all these values here, okay? So those are numbers we can, those are number pairs, factor pairs that yield a product of 216, right? So those numbers multiplied together equal 216. Okay, so I want you to try 150 on your own right now, and the play pause it will give you a little question to do that.